Okay, so in this video, we are going to go over the practice problems from our notes, the energy changes and heat capacity notes. So let's go ahead and turn to the first practice problem. So I'm only going to go over the first one, and then you're responsible for completing the rest. Okay, so let's get started. All right, so our first practice problem says this: a student uses 125 grams of hot water in a laboratory procedure. Given that the specific heat of water is 1.00 cal over gram degrees Celsius, calculate the amount of heat required to raise the temperature of 125 grams of water from 20 degrees Celsius to 100.0 degrees Celsius. So now, that may seem like a lot, but let's break it down. So remember that this is our equation, Q equals M times C times triangle T. So let's go ahead and remind ourselves what each of these mean. So Q is our energy. Our units for energy is calories, C-A-L. It is cal, okay? So, all right. Now, our M is going to be our mass. And this is oftentimes in grams. Okay, and then our C, this one is a little bit more complicated. This one is our specific heat. Heat capacity. So now this one is the units that are combined. So this one is the cal over, oops, cal over grams degrees Celsius. Okay, so this one is the one that has the combined units. Okay, and then the last one is our change in temperature. So sometimes the change is given for us, or sometimes we have to calculate. So if we have two temperatures, we're always going to take the final, so that's the ending temperature, minus the initial. That's the starting temperature. Okay, so this is when we're looking at our change in temperature, our triangle T, it's always the ending temperature minus the starting temperature. Okay, so now that we reminded ourselves of what each of these mean, let's go ahead and get started. So let's go ahead and collect our information. So now, most of the times, what we are going to do is we're going to solve for Q. That is what we're going to be looking for. So let me go ahead and put a question mark right here. So most of the time, we're going to look for our Q. And what tells us that we're looking for our Q? Well, if we go back, it says right here, calculate the amount of heat. Remember, heat is energy. So we are going to calculate the amount of heat. That means that we are looking for Q. Okay, so now let's go ahead and start gathering the rest of the information. So now our mass, remember, is in grams. So we're looking for the number that has a G, grams. So a student uses 125 grams. Here we see a mass, grams of hot water. So we know that how much hot water we have? We have 125. So let's go ahead and add that to our information. So our mass, our M, is 125. 125 grams. Okay. Now let's look for the next thing. So of hot water in a laboratory procedure. Okay, so given that the specific heat of water is 1.00 cal over gram degree Celsius. So now we have another number right here, and it has a combined unit. So we should know that the combined unit is a specific heat capacity. So this is our C, our little c. So let's go ahead. I'm going to go ahead and highlight this in a different color. This is my little c. Remember, it's the combined unit. And we have 1.00 cal over grams degrees Celsius. And now let's continue. Let's look to see what more information we have. So we know we're calculating the amount of heat required to raise the temperature of, here's the 125 grams again, of water from 20 degrees Celsius to 100 degrees Celsius. So now here we have temperatures. Okay, so do we have one temperature or two temperatures? We have two, right? The 20 and the 100. So from, that means that's our starting temperature, and to, that means that is our ending temperature. So we are always going to take the final, or the ending, minus the initial, or the starting. So let's go ahead and add that to our information. So the final, which is 100.0, minus the initial, which is 20.0. Okay, so you can go ahead, plug that into your calculator, and, and you should get 80. So 100 minus 20 should be 80 degrees Celsius. Okay, so now we have collected all of our information. We have our M, we have our little c, and we have our triangle T. And now we can plug it all in, multiply it to find our Q. So let's go ahead and add that to our calculations. All right, so that should be, our M is 125. So let's go ahead and put 125 times our C is 1.00, and our triangle T is 80 because we already did the math. Okay, so go ahead and plug that into your calculator. And okay, so let's plug it in. 125 times 1.00 times 80 equals, all right, that is 10,000. So that's going to be 10,000. And this is 10,000. What are our units for our Q? That is going to be cal. 10,000 what? 10,000 calories. Okay, and this here is our answer, 10,000 calories. Okay, so let's go ahead and summarize before we end this video. So reminder, our equation is our energy equals the mass times the specific heat times the change in temperature. So in our problem, we gathered all of our information. We know we have our mass is 125 grams of our hot water. And the specific heat of water is 1.00 cal over gram degree Celsius. We want to calculate the amount of heat that is required to change from 20 degrees Celsius to 100 degrees Celsius. So we gathered the grams, the specific heat, and the change in temperature. We multiplied all of those numbers together to get the amount of energy, or the amount of heat. Okay, so I hope this helps. Please do the same thing with the other problems, and ask any questions if you still have them. Okay?